So here we're looking at quadratics again, and part of my hint for that is that I've got an x squared. So this is a rather ugly looking problem, but really what we're looking at is just a quadratic fraction. And there's a few things, like we do with most quads, that we want to think about doing here. So the number one step, you need to factor top and bottom of the fraction. And remember, when you're factoring quads, you need to put it into double brackets. So if we take a look at this setup, we have a quadratic on top, but the bottom is just already as simple as it can get. It's in one set of brackets and it's not a quad, so we can leave that exactly as it is. So we will keep the x minus 9 on bottom. And I want you to think about factoring that top. We need to imagine for ourselves what will times to negative 27 and what will out of that add to negative 6. So if we think about 3 and 9, they times together to give you 27. And how can I get a negative 6? Sorry, how can I get a negative 6 out of adding these together somehow? So I have to watch out. I have a negative 27, so I need to make sure that one of them is negative and the other one is positive to get a negative 27. And if I pay attention, the negative 6 here means the bigger one of those two numbers is going to be the negative. So 9 is the negative and 3 is the positive. And the reason I can check that here is that positive 3 minus 9 will get you negative 6. So we're back to what they were asking for. And now that we have the top and bottom factored, we can think about checking to see if anything cancels. So we look for things that are identical, and in this case we do in fact have things that are identical. We have an x plus 3 in brackets, but we also have a bracket x minus 9 on top and a bracket x minus 9 on bottom. And the exciting part is that those will simplify just like 3 divided by 3 will equal 1. These will cancel each other out, and you're left with, as your final answer, just x plus 3. So they can ask this question in various formats. This is probably the simplest, where you just need to factor one thing on the top and then you look at simplifying. So let's look at a second example. In this case, we're going to look at this one. Now we've got a quad on top and a quad on bottom. So same steps apply. First we want to factor top and bottom. So if I think again, what times is to negative 27 and adds to negative 6? Well, we just did that. It was x plus 3 and x minus 9. And now let's look at the bottom, another quad. So in this case, I want to think about what will times to 12 and add to 7. Well, timesing to 12, I can do 2 and 6, but I can't get 7 out of that, or 1 and 12, but I cannot get 7 out of that. And my last one is 3 and 4. And in fact, 3 plus 4 will give me 7, so I know both of those are positive. And it works out for me. Now that I've got it factored, I can stop and say, hey, what's the same? And in this case, I've got two sets of brackets that are exactly the same, x plus 3 and x plus 3. So if those cancel away, my final answer will be x minus 9 over x plus 4. You could write it without the brackets like this, or if it's more comfortable for you, you can leave the brackets on there. And that would be your final answer. And looking at the third version that they often throw at us would be something like this, where we have x squared on top, so another quadratic, but we also notice we have an x squared on bottom. Slightly different format though. But let's look at factoring the top one first. Again, what times this to 12 and adds to 7? We just did that, and it's 3 and 4, both of them positive. So we have x plus 3, x plus 4. Now on the bottom, this is a quadratic in a sense that it's got an x squared, but it doesn't have all three terms, so we might be able to do something different with this. Let's think about it and ask ourselves, is there something both of those terms share in common? Well, this one has a 3 and that one has a 9, but 3 3's make 9, so I can actually pull a 3 out the front. And this one also has an x squared and this one has an x. They both have an x. I can pull an x out the front. and now I'm going to put down my bracket. So I know I need to think now, 3x times what will get me x squared back again, because I've already pulled out one of the 3's and one of the x's. So what's left in there is just 1x. So 3x times x will get me x squared back again. The positive plus sign stays where it is, and now I can ask myself, what times 3x would get me 9x back again? Well, in this case, it's 3. 3x times 3 will get me 9x, and I'm back to where I started again. So now I've factored both top and bottom, like we do for these problems, and the next thing I'll look at is what do they both have in common. And here I can see there's a plus 3 and a plus 3, and bracket x plus 3 and a bracket x plus 3. Identical things, and I can cancel them off. So my final answer will be x plus 4 all over 3x. And you can leave the brackets again if you prefer, that's just fine. And one thing to keep in mind here is that some students like to think about doing things like this, where we have, say, this problem. They might think, oh, well, I see things that are the same, I'm going to cancel off that x squared and that x squared. But we cannot do that. That's illegal. Bad move. Illegal. And our reason for this is that if you pay attention to the fact, this x squared is actually being added to other things on the top, and this x squared is still being added to other things on the top, and because of that we're unable to just cancel them away. When you look at this example, what we wanted to cancel was the 3 plus x, or the x plus 3, and that whole thing is in fact only being times to the stuff next to it. And same here, the whole thing down here is also only being times, so we can in fact cancel it. So whatever you do, don't do this one. Illegal.